Alright, so here is a video of how you use Excel to do some of Chapter 4 problems. I'm going to start off with the exact same problem that we have in the original video, so you can see how to kind of do the calculations. So here's the same table from 4.1, again created in Excel, as well as the same table that I have a picture of in Chapter 4 probability video. So again, to find the probability someone uses drugs, right? We are looking at this row right here, these two numbers, right? So a quick way, if I want to add this row, I just go past it and hit the auto sum key, escape, fine, which equals sum, and I highlight, no, they don't have the numbers in it because I put the words. So this is not going to work as well. So we're going to just type the numbers in, 45 plus 5. If you don't put the words in, you can just do what I was showing, but because I put the words in, you can't. So then equals the sum of 25 plus 480. And now if I auto sum this row, I get to 555, which is in the other video. And same thing if I want to add this column, sum 45 plus 25 equals sum 5 plus 480. So if you create the table, don't put the words in, and you won't have to do it that way. So remember, probability is success over total. So to find the probability someone uses drugs, I am worried about this row, which you can see success is 50. Actually, I'll just call the thing. So that cell divided by our total, which is 555. And then if I want to turn it into percent, I click the percent key, and then we typically want to go one decimal place. So this is exactly 9%. The probability I get a negative test is the negative row, which is the 485 divided by 555. Again, if I want it in percent, in one decimal place, 87.4%. Probability this uses drugs and test positive, right? So this is test positive, use drugs. Well, that is just the 45. So equals 45 divided by 555. Again, if you want to leave it in decimals, you can. So I'll go to 3 decimal places. And these little keys here move and round, do all the rounding for you. And this is the additive law, right? This is probability or. So this equals the probability uses drugs, we said is 9%, plus the probability that they test positive, right, which is this number divided by 555. And then we have to take out the double count, which is minus the 45 divided by 555, because we've counted the test positive twice. And my computer's thinking. Why aren't you working? Fine, it might be because I mixed percentages with decimals, so let's just fix this. Probability someone uses drugs is that divided by 555. Turn it to a number. Why? There we are. I just had it. Oh, wait, I was too impatient. 13.51. Again, we go to one decimal place. 13.5%. So these are the same numbers that I explained in the video. The one thing I didn't talk too much in the video was counting, right? So counting is a way to find the total really fast. And two things in counting that we really use, you can look at the notes, but there's the permutations and combinations. Permutations is when order matters, so order matters. And the other one is order does not matter. Okay? So, here's an example. Say we have 25 students in our class. I want to pick 3 of you. Pick 3 students. All right, and that's how you know you're doing a counting problem. You have a total, and you're picking so many. So now what we mean by order matters. So order matters is after you create an outcome, if I change the order of the outcome, does that create a new outcome? If the answer is yes, then that is a permutation problem. If the answer is no, that is a combination problem. Permutation, combination. So an example of this, say I need to pick 3 of you from the class of 25, and the first person that gets picked is going to present some statistical analysis of their project. The second person I pick will be their backup, and because typically someone's always absent, we'll pick a third person to have a backup to the backup. So, if you get picked first, and say I get picked second, and John gets picked third, if I change the order, you no longer will be the first person presenting. So, that's what it means to order matters. So to calculate that in Excel, it's equals PER, there it is, permute. Right? And at first it wants the number. That is how many people. So 25. And how many are we picking? 3. So we're picking 3 out of 25. And order matters because, again, if you get picked first, you have to present your project. If you get picked second, you are the backup. So if I change the order, you are now first. So that's why it is a orders matter. So there's 13,800 different ways that I could pick 3 students out of 25. Combinations is the exact same thing, but it's called combin, where you again put in 25, comma 3. And you can see there's a lot less, only 2,300 different ways. And the reason is because order doesn't matter. So when I move people around, it doesn't create a new outcome, so therefore I won't have as many outcomes. An example of this, 25 students, I pick 3 of you, and say we're in a classroom environment, and the 3 that I pick have to stay and help me put the class back together and clean. Right? So it doesn't matter if you get picked first, second, or third, you have to stay and help clean. Unlike in the other example, the person that gets picked first is the primary, the person that gets second is the alternate, and the person that picks third is the backup. And if I change the order, we have a new primary, alternate, and backup. So this is kind of how you use Excel to do some of the things that are with the Chapter 4 handout. Again, if you go to week 3, open up the blog. I put a PDF in there of all my notes for Chapter 4 that supports the reading and supports both the Excel video as well as the Chapter 4 probability video. So let's do 1 or 2 homework problems just so you can get an idea here as well. So I'm going to leave Excel up because I'm going to use it as a calculator. Bring it over here a little bit so I can move my windows around. Alright, so there we go. That's the homework problem I picked. So this is 1 out of 4.3. So in a certain country, the true probability of a baby being born a boy is 0.514. Among the next 5 randomly selected births in the country, what is the probability that at least one of them is a girl? So if I bring up my Excel, right, we know boy is 0.514. Now to calculate this would be very time consuming, but the trick and why I picked this problem is the words at least. At least should jump out as a complement problem. So if I wanted to find the complement of this, which is the opposite, remember the probability of an event plus the probability of its complement equal 1. So the complement of at least one of them being a girl is that I have all boys, right? So I can easily find the probability of having a girl. Girl equals 1 minus that number, right? Because that is the complement. And if I add these 2 up, I get 1. So that's another way to prove its complement. However, if I'm having 5 kids and I want at least one to be a girl, the complement of that will be if I have a boy, 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 and boy. 5 kids, all boys. That is the opposite of having at least one girl. So therefore, that is equals 1 minus the probability of having all boys. Well, let's separate this so you can, I don't want to go too fast. So the probability of having all boys is the probability of a boy, oops, if I put my equal sign in, times the probability of boy, times boy, times boy, times boy, because they're independent. So I can either times it by itself 5 times, or I can just raise it to the 5th power. So the little caret key makes it to raise to the 5th as an exponent. So there's the probability of having 5 boys and 5 kids. So to find the probability of at least one girl, that will equal 1 minus the probability of having all boys, right? So 0.964, 3 decimal places, 0.964. There you go. So key thing here for the why I did this question is the at least is a quick way to realize you should probably do the complement. Because if you don't do the complement, you got to find the probability of having 1 girl, plus the probability of having 2 girls, plus the probability of having 3 girls, plus the probability of having 4 girls, plus the probability of having 5 girls in different orders, which kind of goes back to the combination thing, because I can have 2 girls, then 3 boys, 1 girl, 2 boys, and a girl. There's lots of different ways to calculate that, so it's better to do the complement. All right, so perfect. So let's shrink this down. Here I have a table, so I can open it in Excel, and it will create the table very similar to the one I just had in the video. Well, in this video. So I get it to open. And now it doesn't have all the words in there, so you can actually do the calculations, right? So now I can just highlight and do the auto sum thing. So this is a conditional probability, and the reason I know it is it has the word given. So if you go pull back to the handout, the probability of an event given an event equals the probability of the 2 events together as an and divided by whichever one you're looking for. So find the probability of a randomly selected student who spent the money given the student had 4 quarters. So just like I had in the previous video, we are only caring about the 4 quarter people. That's it. Because it says given they have 4 quarters. I don't even care about the dollar people. So I add all this up. That's how many people had quarters, right? And now spent the money is the 30. So that is my success. So this equals the 30 divided by my total. And it wants 3 decimal places, so 7317, so that becomes 0.732. 0.732. So this is how you can kind of use Excel by applying rules, but you have to understand the rules. There's, besides the permutations combinations thing, there is no like quick ways to do things like with chapter 3. Right? You have to apply the things that we were learning from this section, right? So permutations and combinations are in there with their little permute and combin, but everything else you got to kind of apply the rules that are in the handout. All right, please email me if you have any questions. Have a good week.